electric motor. On the output shaft from the motor there's a worm gear. This worm gear is driving the wheel down here. For one turn of the worm, this gear down here will turn one tooth. So it gives a big reduction between the output shaft and there. There's 10 teeth on that gear down there, so this needs to turn 10 times to turn that once. Here we have an electric motor and a compound gear train. That's the drive there coming out of the motor. It's on a small wheel, and that in turn is driving a large wheel, this one on the outside. You can see that the small one is going faster than the large one. The large one is attached on to a second small gear here, which in turn is driving this large one. So you can see the speed that this one's rotating, and this one is much slower than that one. So if you go from a small gear to a big gear, you reduce the speed. Behind this large one, there's another small one which is driving this large one. So you can see the output shaft here is going very slow compared with the input drive there. I think we've got a reduction of something like 25 to 1 between that gear and this output here. On the output shaft there's a windlass, and we've got it winding up a load. If we know the speed the shaft is turning at and the circumference of the shaft, we can work out how fast we're lifting the load. Okay, here we have a system of gears. We've got the worm, which is driving this 10-toothed wheel. So we're going to find out the speed that this windlass is turning at, and we'll find the speed that's lifting up the rope. Right, so start off here. For every one turn the worm makes, this one tooth of this wheel turns. So the speed of this wheel gear here will be 160 divided by the 10. Okay, so the speed equals 160 divided by 10 equals 16 rests per minute. So that will also be the speed of this 20-tooth gear. That will also be going at 16 RPM because they're attached together. This now becomes our driver, 20-tooth driver, so it's driver 20 divided by 80 times 16, so 20 over 80 times 16, that equals 4 RPM. So this gear here, these two are doing 4 RPM. Now this one here, the 20 is attached, so it's also doing 4. So again, this is now your driver, so it's driver over driven times the input speed. So again it's 20 over 80 times 4, so that equals 1 RPM. So this shaft here is doing 1 rev per minute. To find out how fast the rope's going, we need to find the circumference of the drum here that's been wound around. So the circumference equals pi d, or 2 times pi times r. Okay, we've got the diameter here, so it's pi times 10, so that's 31.4 millimeters. It does 1 rev in a minute, so in 1 minute it does 1 times 31.4 millimeters. Okay, so in 1 minute the load will move 31.4 millimeters.